In question number 16, in column 1, different systems are given and point P is indicated where temperature and temperature gradient has to be matched with entries given in column 2. So if I check the entry A of column 1, a uniform rod of thermal conductivity K with ends maintained at temperature TA and TB, and TA is greater than TB. So in this case, this end is at temperature TA and the temperature of this end is TB, and it is given that TA is greater than TB. So the heat will flow in this direction. So I can write dQ by dt is equal to K into area is A into dt by dx. So let this is dt by dx. So this dQ by dt can be written as TA minus TB into L by K. So this is constant because the rate of heat flow through each cross section is same. So we can say that from here, since K is fixed, A is fixed, so dt by dx is constant. So the temperature gradient will be constant. It means the temperature is varying linearly from A to B. So the temperature at the midpoint, which is point P, can be written as T1, that is TA, plus TB by 2. So if I check the matching, then R will be the correct matching, and from S and T, since dt by dx is constant, so the correct matching is only R. In entry B, a cylindrical rod with inner radius R and outer radius 2R maintained at TA and TB respectively. Point P is at a distance 3R by 2 from axis. So in this case, suppose if I consider a section at a distance X and this length is L, this is a cylindrical section. So the rate of heat flow through this cylindrical section dQ by dt can be written as Ka. So A is 2 pi x into L into dt by dx, and the rate of heat flow through each cylindrical section is constant. So I can see here x into dt by dx is constant. So as x increases from R to 2R, dt by dx decreases. So out of S and T, the correct matching will be T. And now I have to find out what is the temperature at point P. So the temperature at point P can be found out by writing this equation in this way: dx by x is equal to some constant, let k dash, into dt. So if I integrate this equation for first for R to 2R, writing the temperature limits from A to B, and then integrating this equation from R to X and the temperature limit from TA to TP, and solve for the value of temperature at point P, then we will find that the temperature at point P in this case is less than TA plus TB by 2. So the correct matching will be Q. So the correct matching for entry B is Q and T. Let's move to entry C of column 1. In entry C of column 1, a spherical conductor with inner radius R and outer radius 2R maintained at TA and TB respectively, and point P is at a distance 3R by 2 from center. So in this case, if I write the equation dQ by dt, so this is equal to K times, if I consider a spherical section at a distance x, then its area is 4 pi x square into dt by dx. Since the rate of heat flow through each spherical section is same, so this is equal to constant. So we can say that x square into dt by dx is equal to constant. So as I move from R to 2R, as x increases, dt by dx decreases. So the correct matching will be T. And in order to find out the temperature at point P, I can write this equation as dx upon x square is equal to some constant, let k dash, into dt. So if I integrate this equation for two cases, first from R to 2R, then the temperature limit is TA to TB, and in the second case from R to X and the temperature limit from TA to TP, then I can find out the value of TP, and in this case also the value of TP comes out to be less than TA plus TB by 2. So the correct matching will be Q and T. In entry D of column 1, a rod of length L with temperature of ends maintained at TA and TB as shown, TA is greater than TB. So in this case also, if this end is maintained at temperature TA and this end maintained at temperature TB, then the rate of heat flow dQ by dt can be written as K times A. So suppose I am considering a cross-sectional area at this x, then I am writing in the way A into dt by dx. So again the rate of heat flow through each cross-section is same, that is constant. So since the cross-sectional area is decreasing as I move from section A to section B, then dt by dx will increase. So in this case, in order to calculate the value of temperature at point P, the cross-sectional area is varying. So I have to write the cross-sectional area as pi into r square. So I have to write the radius at this point, which can be written as, suppose if this radius is r1, then this radius is r2, then we can find this as r1 minus r2 divided by L into x. So radius can be find out, area would be pi r square. So if I solve this problem, then the temperature at point P comes out to be greater than TA plus TB by 2. So the correct matching will be P. So the correct matching for entry D is PS. So in question number 16, the correct matching for entry A is R. For entry B, it is QT. For entry C, again QT. And for entry D, it is PS. Let's move to question number 17. In question number 17, two particles A and B are executing SHM on same line with same frequency omega naught and same amplitude A naught about the same mean position. At time t equal to 0, the distance between A and B is maximum and is equal to root 3 A naught. Based on the information given in column 1, match the entries in column 1 with the entries in column 2. So in order to analyze this problem, suppose I am drawing a phasor diagram of this SHM. Let this is the circle and the particle is performing SHM on the y-axis. So when the separation between A and B is maximum, then the velocity is same between both the particles. So in that case, we can say that either these two particles are moving in this direction. Let this is A and this is B. So they are moving in this direction, or they are moving in this direction. So this separation would be root 3 A naught by 2. So suppose at this moment, if I take the position of the particle moving in a circular path, either is at this position or is at this position, and for B, it is either at this position or this position. So in this case, if I calculate this angle, then this angle comes out to be pi by 3 or 60 degree, because this is A naught, this is root 3 A naught by 2. So this angle comes out to be pi by 3. Similarly, this angle also comes out to be pi by 3. If this angle is pi by 3, then this angle is also pi by 3 and this angle is also pi by 3. Let's check the entries of column 1. In entry A, phase difference between two particles. So phase difference between these two particles when they are moving in this direction is this much, and this is equal to 2 pi by 3. So the correct matching is Q. And when they are moving in this direction, then the phase difference between them is this. So this can be find out, and this is equal to 2 times of 120 degree, and this phase difference can be written as 300 minus 60, so that is 240 degree. So this can be written as 4 times pi by 3. So the correct matching will be Q and T. In the entry B of column 1, it is given that displacement from mean position when particles are at same position is A naught sin theta, the value of theta is. So now I have to find out at what position they will have same displacement. So suppose this when A is moving in this direction and this also moving in this direction, after some time when the projection of this particle is comes to here and this is moving in this direction, means particle on a circular path is here and this particle is here. So in that case, if I find out what is the angle this B has rotated, suppose it has rotated from here to here, at this position they will have same displacement. So this is rotated by an angle of pi by 2. So if this is rotated by an angle of pi by 2, then this is also rotated by an angle of pi by 2, then it moves to this position. In that case, if I find out, so this angle comes out to be pi by 6. So the correct matching of entry B will be R. Now in entry C, if t is the time when particles are at same position, then value of omega naught t. So in that case, the value of omega naught t must be equal to pi by 2. So the correct matching will be P. And in entry D, if t is the time taken by A to reach mean position, then value of omega naught t can be. So in that case, if A has to reach the mean position, this is A and this has to reach the mean position, then A has to move in this way and reach to mean position. In that case, it has to travel an angle of 120 degree or 2 pi by 3. So the correct matching will be Q. If this has to move to this position, then this has to travel this much and the angle it has to rotate is by pi by 3. So the correct matching will be S. And one more case, it will reach to mean position if it moves in this direction further and then come back to this position. So in that case, that is pi by 3 plus pi. So it is equal to 4 pi by 3. So the correct matching will be T also. So the correct matching for entry A is QT, for entry B it is R, for entry C it is P, and for entry D it is Q.16. Let's move to question number 18.